balloon is being inflated and the radius of the balloon is increasing at a rate of 2 centimeters per second. So part A, express the radius of the balloon as a function of the time t in seconds. So they're asking us to, basically you can write it in function notation. We're getting an equation for a radius, but t is the variable. Okay? So we need an equation for radius using t.
R equals T at T equals A.
So let's see. Let's do this. At time 0, what's our radius?
0.
Okay, after 1 second, what's the radius?
2.
After 2 seconds, the radius is?
Square.
After 3 seconds, the radius is? 6, because it's going up 2 centimeters every second. So after 4 seconds, it would be at?
8.
After 5 seconds, it would be?
10.
Can you tell me an equation?
2 times t.
It goes up 2 centimeters every second, so the radius is just 2 times the number of seconds. Alright, B. If V is the volume of the balloon as a function of radius, find V composed with R and interpret it. Okay, so we are finding V composed with R, or V of RT. How do we find volume of a sphere? Almost. Cute.
Thing.
How do you know that?
Yeah, what?
What are you doing?
Nothing.
You guys don't know that? No, no, that might be the year. We use that one a lot. This would be a formula I would give you at this point. Now, if it were like area of a triangle, volume of a box, those kinds of things, I would expect you to know. But length times width times height or volume.
Area of a triangle?
1/2 is okay. Half of a rectangle. Rectangle's length times width or width times height.
We're not talking about a prism, right? Just a rectangle?
Yeah.
Well, just a.
Yeah, if I wanted like volume of a pyramid, I would give you that.
Oh,
That's the length.
You don't learn that in
What is the volume?
I think you should figure it out.
Yeah, Carson, you would know that. I have a sphere.
Well, what type of pyramid?
Wait, what kind of pyramid? Is it a
It's a good question. So if we,
Is it a
let's
square
say
base?
a rectangular base.
rectangle?
Okay.
It would be half of it, wouldn't it? You just take.
It's
times height divided-
basically a third.
Yeah.
Oh, a
So-
third.
1/3 times space times height.
Okay.
Cube.
It'd be like length times width times height, and then a third of that.
Weird.
Okay, so if I'm asking for V composed with R of T, all I'm asking you to do is basically take the formula we just found for R and plug it into this formula. So my R is 2T. If we simplify this, 2 to the third is 8t cubed. 8 times 4/3 would be 32 over 3 pi t cubed. So this is basically a formula for finding the volume at a given point in time. All right. Then it asks me to interpret it, which is really what I just said. So this formula is the volume of the balloon at a given time. Huh?
How do you know that it's the formula is the wrong?
Well, because we use the volume formula, so we know it's finding volume, and our variable is time. The original volume formula would give the volume if you knew the radius. We basically cut out a step. We don't have to find the radius now, we can just find the volume. Other questions, sir? Let's look at another one. An airplane is flying at a speed of 350 miles per hour at an altitude of 1 mile and passes directly over a radar station at time t equals 0. Express the horizontal distance d that the plane has flown as a function of time t. Okay, I need a picture. So here's my radar station. At time 0, my plane is directly overhead. Come on in. And how high above the ground is it? Okay, and it's, since it's flying horizontally, that's not changing. So now my plane is flying, and I am quite the artist, so I'm going to draw myself a little plane.
That's a very good airplane.
Thank you.
I don't actually think I can draw an airplane.
So,
I drew a fish. Is that the same thing?
oh. So the distance it has flown as a function of time t. So my plane is flying here. This is my distance. I want a formula for it. So I'm looking for d of t. Give me a formula for distance where t is my variable. So at time 0, how far has it flown? 0. After 1 hour.
350.
After 2 hours.
700.
Okay?
1050.
350 t. Alright, B. Express the distance between the plane and the radar station as a function of d. Okay, so the distance between the plane and the radar station, that's this. That's S.
Oh
Is
yeah.
that a right angle I see?
I
there?
would assume since this was horizontal and this was vertical. So you could say 1 squared plus d squared equals s squared. So s is the square root of 1 plus d squared. Okay, so we had to find our formula for s in terms of the distance, which we did. Now part C, use composition to express s as a function of t. So I don't want d as my variable anymore. I want it to be a t. What can I replace my d with?
0.
No,
350 T.
d is 350 t.
Oh.
Kaboom.
Don't ever say. Don't.
Yeah, no, I would.
Okay.
Good.
If it were a nice number like 3, I would tell you to go ahead and make it 9t squared, but I don't really want to write 350 squared, so I'm just going to leave it like that. So now you could find, at any given point in time, how far the plane was from the radar station. Oh, we would figure it out.
I would just like to say I am having trouble. It happened the last time too. Getting that first equation. Like I don't know how the process you're going through in which to get 350.
So I was just kind of thinking about it. So at time 0, the plane hasn't flown anymore. After 1 hour, the plane is 350. After 2 hours, it flies another 350 miles, so now it's 700. After another hour, it goes another 350. Okay, it's kind of like a line. Y equals mx plus b, because it's going up by the same amount every time. Your slope, how much is it going up by? 350. Okay, so it's like kind of like this. Plus, your y-intercept at time 0, you started at 0. So it's essentially this. I just use d and t instead. What?
What?
Oh, that's one. Oh. I didn't realize that was one.
That's one. Okay.
I was trying to figure out what L we
Where
were
the
looking
got an
at.
L?
Lowercase L?
Yeah, you know how in math we notoriously use lowercase l's.
Take a second and see if you could start this problem. We'll just pick it up here and make sure everybody's on the right track before. Okay. So we have an oil tanker crashes, develops a leak. We're looking at the radius of the oil spill increases 1.5 inches per second and has a constant depth of 1 inch. So what is the radius as a function of time?
5t.
Okay. Volume. So this is like a cylinder, right? Where you've got a circle, but it has depth to it. So when you're thinking volume, it's basically like area of the base. So the base is a circle. What's area of a circle?
R squared.
Times the height.
My bad. Conscious.
So we want the volume as a function of t. So t can be our only variable. What would I replace my r with?
1.5t.
1.5T.
Hey, I did it.
And then what do we know about our height?
It's 1.
It's a constant depth of 1. So 1.5 squared would be 2.25 pi t squared.
Could you do t squared pi with that because it's commutative?
Yeah. So interpret it. What does this formula give me?
The volume of the cylinder at any given time.
Or the volume of the spill. Or the amount of oil that has spilled.
I had to correct how I spelled cylinder because I spelled it wrong. You're going to tell me spill?
Alright. Is that okay? Final problem. A stone is dropped into a lake, creating a circular ripple that travels outward at a speed of 46 centimeters per second. So A, the radius as a function of time. What would it be?
46t.
I want area as a function of time. So what shape are we creating with our circle? What's area of a circle?
R squared.
So area as a function of time, you replace your r with
46t squared.
you could leave it like that. I don't know what 46 squared is off the top of my head.
I didn't see your calculator out, and I thought you just
Yeah, I just knew that.
thought you just did it. You know.
Kind of insane in my head.
You just like to memorize perfect squares, right?
I hope it's 46.
Oh, yeah. She doesn't go to 50. No, she stops
Not
at
anywhere
46.
past 46, not 50.
You ask her what 50 squared is, she doesn't know. But
So what would this formula give me?
the area of the ripple at any given time.
Mm-hmm.
Do I have to say this formula, or can I just?
All right. So now you should be ready to finish that handout.